All right, so today we're going to look at graphing linear functions using tables. So we're just going to use a table to graph lines, right? So linear functions are just lines. And when we say linear functions, they are one single continuous line. So a linear function would be like a line this way, it could be a line this way, it could be a line going this way. It could even be a vertical line. Like these are all lines, right? Those are linears. And so they look like this. And so when we graph them, we're going to learn some shortcuts along the way. But really what we're going to start out with is a table, because anytime you're graphing, no matter it be a linear or a nonlinear function, you can always make a table of values and plug them in, because as we know from last module, graphs and tables and points, they all represent the same data. So if we took an equation, we could fill in a table for that equation, get the ordered pairs, and then plot them, and we would have our graph. So we're going to start out basic with two different types here of a y equals and then an x equals in the second one. But one of the forms that we're going to notice for an equation of a linear, as it can be said, or as it says right here, it can be equation in two variables, is the slope-intercept form is the most common form of a line. Slope-intercept form looks like this: y equals mx plus b. Probably familiar with that from middle school, so that is just the slope-intercept form. So even if I had an equation like this where it says y equals 5, I could write it in this slope-intercept form, because since there's no x, that would tell me that it has to be 0x plus 5, and 5 happens to be the b value. 0 would be the m in this case, because it's the one with x. Okay, that wouldn't change, right, if I did that. And again, we want to write it in two variables, so here I don't have two variables. So if I wanted to get a second one, a variable in x, I could put it as 0x. So this could be, these two are the exact same equation. So if I wanted to graph those, all I would have to do is make a table of values. So I started a table here for you. I even picked the x's. You can choose the x's all you want. These are typically good x's. Sometimes we pick different ones based on the equation, and we are a little bit more picky about what x's we choose, but these 5 x's are really good ones to choose every time, no matter what the graph looks like. And then sometimes you have to go beyond that and whatnot, depending on what the equation is. So to start, we're going to just plug in x of -2. So if I took my equation, doesn't matter which form I plug it, but since this one has an x, I'm going to use this one. And so if I were to plug in -2 for that x, I'd have 0 times -2 plus 5. Well, if I did that math, 0 times -2 is 0, add 5, I'm going to get 5 back. So the point that I would plot then is the x, -2, comma the y of 5. So I could go onto my graph and plot that point. So at -2, so left 2 and up 5, 1, 2, 3, 4, 5, there's one of my points. I could go through and do the next one. I could plug in -1 to this. So 0 times -1 plus 5. Well, 0 times -1 is 0. Add 5. It's going to be 5. So I'm going to have the point -1, 5. I go up here. I'm going to plot that point. -1 up 5. I'd be up here. I could keep going with this process, right? I could add in 0 here. So 0 times 0 plus 5. 0 times 0 is 0, add 5 is still going to be 5. So I'm going to have the point x0, y is 5, so 0 up 5. If I keep going that process, we should recognize that no matter what my graph is, no matter what I pick for my values, right, no matter what I pick for my x's, y is always going to be 5, because that's what that says. Y is equal to 5. It doesn't matter what x is, so y is going to be 5. Even if it's 1, it's going to be 5. If it's 2, it's 5. If it's 3, it's going to be 5. If it's 0.5, it's going to be 5. Right? And so it doesn't matter what my x's are, the y value is always going to be 5. So when I look at this, I have all these points. Well, like I said, it could be 0.5, 0.25, 0.1, right? All of those would still work, and I would still get 5 out. So this is not a discrete function, even though we just have specific points here. We're going to have a full-on line of continuous function, and so it's going to be this line right across where y is 5. So in other words, the idea of this is when I have a graph in the form of y equals some number, whatever that number is, if it's just y equals that number and there's no x, it's just a number, we're going to end up with a horizontal line. Or I guess vice versa. If I have a horizontal line, I'm going to have the equation of y equals whatever that number of the y values are, right? All the y values on this entire horizontal line are 5. And so that's why the equation is y equals 5, because it's a horizontal line. So what I'd like you to do is pause the video in just a second, because what I want you to do is graph the equation y equals -3 on this graph. Okay, so go ahead and pause the video. Take about 5 minutes to do so. All right, if I'm going to graph y equals -3, that means all the y values are -3. And since it's in this form, I'm going to have a horizontal line through -3. So go down 1, 2, 3. And so then my horizontal line is going to be right through there. That right there is going to be the horizontal line y equals -3. This one up here, remember, was y equals 5. What would the equation be, think about this, if I had this horizontal line right across here? If that was my graph, the x-axis, what would that equation be? What are all the y values of that line? The y values are not going up or down from the x-axis, so the y values are 0. So that equation would be y equals 0. Okay, so even if I had the line, I could write the equation because, again, it's always, if it's a horizontal line, it's going to be in the form of y equals some number. It should make sense then when we do the x equals, we should know what to expect in this one. Okay, so when I look at the x equals 1, we can still make a table of values. So if I go x and y t-chart, okay, well, here's the problem, is my equation already tells me what x has to equal. It has to equal -2. Can I make x equal anything other than -2? The answer is no, right? Because if I even put another number in there for that x, I would not get a true statement, and that means it's not on the line. So my only option for x is -2. And so that means I get to plug in -2 for that. I'm going to get a true statement, so that way it doesn't matter what the y is. The y could be 4, the y could be 0, the y could be -3. Wouldn't matter what the y value is, x has always got to be -2. So if I go over -2 and up 4, 1, 2, 3, 4, plot that point. If I go -2, 1, 2, and plot that point at 0, and -2, -3, over -2 to the left, and down 1, 2, 3, you'll see that all those points are going to be a vertical line. So this vertical line is at x equals -2. So in other words, anytime I have x equals some number, okay, anytime I have that kind of thing, I'm going to have a vertical line. And vice versa, right? If I have a vertical line, I can write the equation of that vertical line based on where the x values are on that line, okay? So just like before, I want you to graph the line x equals 4, okay? So pause the video, take about 3 minutes to graph the line x equals 4. All right, x equals 4 should be right down here because all of the x values, 1, 2, 3, 4, all the x values are at 4. That is x equals 4. Then comes this think about it we talked about last module. Is this a function? Would it pass the vertical line test? And the answer is no, because if I took a vertical line through that, it's going to intersect at every single point. And remember, if it intersects in 2 spots, it's not a function. So that one is not. Would a horizontal line be a function? Yes, because if I cross that, even just the y equals -3 with a vertical line, it's only going to cross at that one spot, right? And so the y equals ones are going to be functions where x equals are not functions because they would not pass the vertical line test, or they would fail the VLT. All right, turn the page. So now what I want you to do is I want you to take about 7 minutes here to first answer number 1 through 4. You're going to tell me if it's a vertical or horizontal line based on the equation. And then down here, there's 4 lines. So line 1 is this one. line 2 is this one, line 3 is this one, and line 4 is this one. Okay, what I want you to do is write the equations of those 4. Okay, so go ahead, pause the video, and take about 7 minutes to answer those 8 questions. All right, so if we look at this of the top, x equals 3. If you're not sure, you don't remember, you're like, oh, I don't remember what the rule is. I had to look back and look at my notes. I don't remember if it's a horizontal or vertical, right? All you have to do is sketch, right? You can make a little sketch of your graph. Here's my x and here's my y axis. Okay, if I had to plot the points of x equals 3, well, 1, 2, 3, oh, that's going to be just like that through all the x's that are 3. So that tells me this is a vertical line. Just like this one, if I wasn't sure, I couldn't remember, if I had the line y equals -2, well, shoot, I can go here, sketch out my graph. Here's my y-axis, here's my x-axis. -2, my y is -2, so that means I got to go down 1, 2. Oh, there's where my y's are -2. Ah, so that's going to be a horizontal line. And then from there, it's just the same thing, right? Anytime I have it in the form of x equals a number, it's going to be a vertical line. So like number 4 has to be vertical. Number 3 is y equals, so that has to be horizontal. So now if we talk about the equations on the bottom. Well, equation 1, line 1, is a vertical line. So remember, vertical lines are going to be in the form of x equals. Let me put it down here too. Okay, that means line 3 is a vertical line. It's got to be as an x equals. Whereas lines 2 and 4 are horizontal lines, so those are in the form of y equals. And all we have to do is figure out what those are, right? At line 1, for instance, what does x equal? It's a little off, but let's just say it's on that line. And so that would be at -1, -2. So that would be x equals -2. Line 3, I'll skip to that one because that's the other vertical one. Okay, and that is through the x's of 1, 2, 3. So line 3 would have to be x equals 3. Line 2 and line 4 we said were horizontals, so it's the y values that we're worried about for line 2. So if we had to go up 1, 2, 3, those are all at y values of 3. So the equation for line 2 is y equals 3. And finally, line 4 is down 1, 2, 3, 4, so that would be -4 is where all the y values are, so my equation would be y equals -4. So that's the lesson, just talking about vertical and horizontal lines. Even if they were not in that format, we could still make a table and plot the points that way. So if you look at the assignment, some of these, like number 1 is in that form, number 2 is in that form, number 3 is not. So if I look at 3, all I'm doing is plugging in, the equation is here, all I have to do is plug in these x values. I gave you 3 of them, just plug in each one to this equation and get the y, and then plot the points. So for instance, I'm given -1 as an x, I would do -8 times -1, -8 times -1 is a +8, so I would plot the point -1, 8, so left 1 and then up 8, 1, 2, 3, 4, 5, uh-oh, I've only got 5. Well, guess what? We don't have to go up by 1s in our graph. We might make it go up by 2s. Maybe we're going to change this to 2, 4, 6, 8, 10. Okay, we can go up by 2s. If the scale is not written like it is in number 4, then you can create it. So you don't have to go up by 1s in here. So we're going to go up by 2s. That way, -1, 8, I can plot that point. Then I'm going to do y equals -8 times 0. Well, -8 times 0 is just 0, so I'm at the origin. Okay. All lines do not have to go through the origin, by the way. Some of them do, but they don't have to go through the origin. In this case, it does. And then I would do -8 times 1, which is -8. So I already labeled these, but let's see, this would be -2, -4, -6, and -8 would be right there. So my other point would be at 1, -8. So here. And then what you can do is you're going to want a straight edge because these are all lines. You can use the edge of your calculator if you want and just kind of line up all those lines on the edge. It's hard to see on the dot camera, but you can line them all up on the edge there, and then you can just draw your line through those points. Because remember, it's going to be continuous. It'll be a line. It'll look like that. And that would be your equation of, or sorry, that would be your graph of that linear. Even though it's not a horizontal or a vertical line, it can still be drawn a line. So that's all we would have to do if it's not a horizontal or vertical line and it's not just x equals or y equals.